Okay, welcome to the latest Gideros tutorial. In this tutorial I want to talk about touch events with Gideros. Events which fire when you either click the mouse button on the screen or you touch a touch device with your finger, move your finger along the screen and release your finger from the screen. Or if you click with the mouse, drag with the mouse and release the mouse. And these are of course extremely important events. It's the essential way to allow the user to interact with your app. In this tutorial I want to go through this project called Drag Me. So this is one of the example projects in Gideros. So if you open it straight away, it's just a single source code file. We're going to launch the player. I'll just make this a bit smaller to be more convenient on my screen. Okay. And if you play this example, what it is a series of rectangles and the text tells you what to do. You can drag the rectangles around with the mouse. Or if you export this for a touch device, Android, iOS or Windows phone, you can drag around with your fingers as well. So clearly it's very important to know how to do this. This is kind of a common task in many different types of apps, like a jigsaw puzzle game or something like that. But also it will introduce us to the very important concept of these events. If we go down to the bottom, you can see that the fundamental events here, which we need to know about, are the mouse down event, mouse up move event, and the mouse up event. And actually they have a set of cousins, or a similar set of events called touches begin, touches move, and touches end. And to a large extent these are overlapping and similar events, but there are some subtle differences which we'll discuss. Okay, so I want to start off with a fresh project. I'm not going to use this one, but I'm going to start from scratch, as I usually do. So let's go ahead and create a new project. I'm going to put my project within Gideros Games. That's the directory I use, and I'm going to call it Drag Me. Actually, I don't need to do that. What I've got is this this checkbox is activated, meaning it will create a directory for the project, and it will name it after the name of the project, namely Drag Me. So within Gideros Games, there'll be a new folder created, because it says create a new folder, and the name of that project will be dragme.gproj, which is the project file for all Gideros apps. Okay. Right, so now I have a brand new project, nothing in it. I'm going to right click on the root of the project and add a new file. I'll add a new Lua file called main.lua, and this will be the only source code file in this project. And also I don't need any assets because I'm just going to draw rectangles. I won't be importing any bitmap sprites into this project. Okay, well the first thing to do is to draw a rectangle. So let's go ahead and do that. I'm going to call it shape, and create it using shape.new. So it's a shape. Remember, every shape is a sprite, but a shape is a special type of sprite which allows you to draw polygons, and you can fill them, and you can have a border around them as well, and they can be filled either with a single color or with a texture. So let's go ahead and do that. For my shape, I'm going to set the line style 3 pixels wide, and its color will be black. I could have just said 0, but I'm going to spell it out there because, as you may remember, colors in Gideros are specified using a 6-digit hexadecimal number. When it's black, they're all 0. Red, green, blue, all set to 0. Let's set the fill style. Fill style comes in 2 flavors in Gideros. There's a shape.solid and the shape.texture. You can view one of my other tutorials to learn about the difference between those two. I'm going to stick with a solid color, and I'm going to get full red, 0 green, and 0 blue. Red, green, blue, and it's just red that I've activated. And this is an optional parameter, which is the opacity. I'm going to make it 0.5, so it's halfway transparent, so you can actually see the shapes when they start overlapping on each other. That's the nature or fill style of the shape, but I need to actually draw the lines that make up the shape. I always start with a begin path, and then I do a move to command, which moves my pen to the coordinate 0, 0. I now have a line to command, and I'm going to draw it 100 along and 0 down, so a horizontal line of 100 pixels wide. Going down by 50. And then we have this, I could just draw it all the way back to the start, 0, 0, to complete the loop, but we have this convenience function called close path, which does that for me, closes the path. So now I have a rectangle. I must also remember to end the path, which actually fills the shape and draws it. And if I actually want to see my shape, I must remember to add it to the stage. Right, so let me run that. Okay, so there's my rectangle, and it's located at 0, 0. I didn't give it a coordinate, so that's why it's at 0, 0 coordinate. Let me put the shape in a random place. Oops. Shape set x, and I'm going to use this standard library function math.random. This comes with Lua itself, so you can look up how this math library works. And there's many functions within it, all the usual mathematical functions you would expect. It's not Gideros specific, it's a standard library from Lua. So I'm going to choose a random number which is between 0 and 220. 320 is my logical width of this panel, of the screen, and I'm subtracting 100 because I know the shape is 100 wide. So I want it to be on the screen, all of it on the screen. Similarly, the y-coordinate will also be a random number, uniformly distributed between 0 and 480 minus 50. Alright, so every time I run this app, it will be at a different place. Okay, so far so good. Of course, we can't move the shape. We haven't done any coding at all to respond to touch events, so it's not moving. We can't drag it anywhere. Let me proceed by having several shapes. I'm going to have 5 shapes, so I'm going to need a do loop, a for loop. Yeah. Let me put this within loop. So end. It's always nice to indent these things within a loop, but of course you don't have to. So this should create 5 shapes, which will be drawn on the screen in random positions, and they're overlapping. Because I set the transparency to half, then you'll be able to see the shapes. They won't entirely hide each other. You'll be able to see one shape through another shape. Okay, let's run that. There you go, 5 shapes. Before I proceed with the dragging and touch events code, it's worth having a look at this loop and just understand the issue of garbage collection and so on in Lua. As you know, I'm sure, Lua is a language where everything exists by reference. So every variable that points to a sprite is holding a reference or a pointer to that sprite rather than the sprite itself. So when we create a new shape using shape.new, shape.new returns a reference in memory to the memory location. And now this local variable shape is holding that memory location. We then add the shape to the stage. The next time we go around the loop, shape.new creates a brand new shape with a new memory location, and this is now being stored in my local variable shape. So the old shape, there's no Lua variable that's pointing to it. So you might think, could the shape be garbage collected? In fact, no, because we've added the shape to the stage, and it's still possible for me to access the shape. And I could access the shape from its parent, namely the stage. I could say stage get child at 1, and that would then return a reference to that very first shape. So because I can still access the shape, these shapes will not be garbage collected. So let's prove this. I'll set the color transform for this shape. The first shape, and you should see it turns black. So let's see if that happens. Yeah, so I can still access shapes and I can still manipulate them, even though I don't have a local variable that's pointing to them. So you may think it's a little bit strange. I'm not maintaining a list of shapes for my own use, but the reason is I don't have to, because Gideros is essentially keeping track of the shapes for me in this case. And what I'm going to do when I start manipulating the shapes so that they can move around under mouse control events is they will take care of themselves. So there's no need for me to have a global list of all the shapes in this case. I could do that. I mean, I could say shapes equals empty array, and as soon as I create the shape I could say shapes I equals shape. Now I've got a list of all the shapes, and I can loop over all the shapes and manipulate them as a block. But in this example I don't need to do that. They won't be garbage collected against my will, and they can take care of themselves, as we'll see in a minute. Okay, well now we've got all the shapes on the screen, it's time to start adding touch events to these shapes. So I'm going to go here and I'm going to say shape, add event listener, and the event will be event.mousedown. And that will refer to a function called onMouseDown. And there's an optional parameter to add event listener. You can either call it with 2 parameters or 3 parameters. I'm now going to call it with 3 parameters, and I'm going to add the shape itself. So what that means is when onMouseDown is called by Gideros, it will pass in this third parameter, which happens to be the shape reference itself. And that's the normal way to use add event listener. So I can therefore distinguish between all the different shapes that will be passed through to this onMouseDown function. So naturally I need to actually write this function. So function onMouseDown, and it goes to end. And because I registered this function with the third parameter, namely shape, when Gideros calls this callback function, the first parameter passed through will be the shape itself, which we normally refer to as self. So I'll call that self. So the first parameter self will be the particular shape that's being called. The next parameter will be a parameter called event, and the nature of this event depends on precisely which type of event is being called. In the case of a mouse down event, it will be the XY coordinates of the event where the user clicked on the screen. So for now, let's simply print out everything that we're getting passed through. Print out self, that will just be a reference, so it will be a sort of pointer number. And let's print out the coordinates. Now you can see from this code that every single shape is being registered with the mouse down event. So whenever the user clicks the mouse on the screen, every shape will have that event dispatched to it. So the mouse down event will be dispatched to all these shapes, and each one will call the onMouseDown function. The only difference is the first parameter will be different for each of the shapes. Okay, let's try running that. Let me click somewhere on the screen. Now, you may be a bit surprised by this, and I sure was. Every shape, you can see all 5 shapes are getting the event, the onMouseDown event, and every one of those shapes is running the onMouseDown function, which causes this table to be printed out. So it prints out self. When it prints self, it prints out a table, and this is the actual memory location, and it prints the coordinate x equals 70, y equals 157. So what you can see in Gideros is when you register a sprite with the MouseDown event, that sprite will always receive the event even if the mouse click did not happen on top of the sprite. So wherever I click, I get 5 events being fired. The MouseDown event is fired to all 5 shapes because they're all registered with MouseDown. All of them then respond by calling on MouseDown with its own self and the same event being passed through. And in some cases this is what you want, but in our case, and in the normal case to be honest, you normally want the event to only fire when the click happens on top of the shape itself, not when it happens outside of the shape. Of course there's a way to do that within Gideros. We're going to make use of this function called hitTestPoint. So what I do is I say if self hitTestPoint, and then what I do is I pass through the coordinates of the touch, which is just event.x and event.y. Event.y. Then we'll print out the ID of the shape and the xy coordinate of the touch event. And this is a very common sort of programming paradigm in Gideros. You very often will test using hitTestPoint. So hitTestPoint, what it does is it takes a coordinate and it says, is this coordinate within myself, within this particular rectangle? If it is, then it returns true, and if that is true, then we'll go ahead and print out the information. If it's not true, then we won't print anything out. And hitTestPoint works for any sprite and shape, even if you rotate, translate, and scale it, and even if it's part of a complex drawing hierarchy with a parent, and then and so on. It can still untangle all that detail and return either true or false if your point is within the shape, and false if it's outside of the shape. So if I run that, okay, if I click outside of any of the shapes, you can see nothing is printed. If I click within one of the shapes, then only one rectangle prints out the information. So the event is still dispatched to all 5 rectangles, but they all go through this function. Then they say, well, is this event happening within me? If it is, I'll print myself out and the xy coordinate of the touch event. So if I click that one, that's that rectangle, that's that rectangle. And if I click away from any rectangle, I get no response. But what you can also see, if I click on a piece that's overlapping between 2, then both rectangles will fire. So now you get 2 of them. And that's not what we want to happen in this case, but we'll look into that in just a moment. Okay, so let's look at what we actually want to do when a click event occurs on top of one of the rectangles. What I actually want to do is I want to add a new field called isFocus. Now this has no significance for Gideros. I'm just adding it for my own convenience as a programmer. Remember, in Gideros there are no significant fields within any object, any sprite object. So if I go ahead and do something like self.x equals 100, that's not going to move a sprite to 100, the location x equals 100. And there are no fields that I can accidentally set. Whenever you want to set something in Gideros, you have to run a method, so setX. That would move the object to position to an x coordinate that you specify. But if you just set a field, it doesn't do anything. So the reason I'm doing it is because I want to keep track of whether this object is in focus or not. But it'll be up to me as the programmer to actually use this isFocus field. So what I'm saying is when a MouseDown event occurs on a rectangle, isFocus becomes true for that rectangle, and of course remains false for all the other rectangles. The other piece of information I'm going to need to record, and again I'm creating a new field on the fly here, is the x coordinate and of course the y coordinate. So as you know, in Lua you can just create new fields on the fly. Self is just a table. I can add new fields just like this. I don't need to do any special initialization to ensure that x0 and y0 exist as fields. So that's all I'm going to do when the user clicks. So remember, what we're trying to do is get a situation where the user can drag the rectangles around. So far nothing's still not going to drag it around. It's just when you click on the rectangle, it's going to make a note of the XY coordinate you clicked on, and it's going to set this field is focused to true for that rectangle. Okay, so that's all that happens for on mouse down. And I need to deal with the Mousemove event. So when the user clicks on the screen, drags while holding down the mouse, every time he drags, this Mousemove event will fire. So again, I'm going to use the 3 parameter version of add event listener, and I'm going to add in the shape event, the shape as the third object. So again, my callback function will look similar on mouse move, self and event, and function ends, and of course self will just be the particular shape that we're interested in, and event will be the XY coordinate of the move event. Now in this case I'm only going to operate if self dot is focus, and you can remember up above I've just set this to be true. So if I just move the mouse across a rectangle that isn't in focus, nothing will happen. It won't move even though there's a move event going on. Okay, I have a local variable called dx, and what that's going to do is going to take the event x, which is the position of the mouse as I drag the mouse across the screen, the current x coordinate of the mouse, and subtract the initial position when I first clicked on the rectangle. And similarly for y, I'll create a variable called dy, and now I'm going to actually move the rectangle. And where do I move it to? First of all, let's see where it is at the moment, and then I add on this displacement. So what we're seeing is it depends how far the user has dragged the mouse across the screen. He clicks on a certain coordinate, he then drags to another coordinate, and the difference between those two is how far the rectangle needs to move. Of course, it's the same for the y coordinate. And now that the object, the rectangle, is now moved to a new position, I need to set the x0 to be that new position. So the next time a mouse event occurs, exactly the same thing will happen. The object will be displaced in the same way again. And all this movement should only happen as long as the thing is in focus. Okay, let's see what that does. So if I grab this, I can now move it. So it works. Okay, so the last thing we need to do is process an event which occurs when the user lifts his finger off the mouse button, namely a mouse up event. So when the user stops dragging, a mouse up event will occur. And we're going to process that using a listener called onMouseUp, in exactly the same way as the other 3 events have been processed. So when the user releases the mouse button, we'll receive an onMouseUp event. That will cause this function to fire. And all we're going to do here is if self dot is focus, then we're going to say set the isFocus field to false. So having raised your finger off the mouse, then the object is no longer in focus. And as if we continue to move the mouse, we'll no longer see any movement of the object. So this self.isFocus will be untrue and nothing else will happen. So that's registered that. So if I run that, I can now move these shapes about independently. So everything works. There's only a slight problem. If I click on the intersection between two shapes, then they both move around at once. Now in some cases you might want that to happen actually. That might be the desired behavior, but in other cases you actually only want one object to move. So what's happening here is that all 5 shapes are getting mouse down, mouse up and mouse move events dispatched to them whenever those events occur. But what we want to do is to make sure that this event doesn't propagate once it's been processed for one shape. So if this is the shape in the front, it processes the event and then it tells Gideros not to allow the event to propagate to the shape that's underneath it. And shapes are processed, touch events are processed in the order from the nearest shape to us, to the camera, and then the shape that's behind it and the shape that's behind that and so on. So the process in a certain order. So to achieve this, what I'm going to do is if I handle the event, I need to tell Gideros not to propagate that event any further. So if I handle a mouse down event, what I do is I say at the end, event, stop propagation. So now the mouse down event will not be propagated to the shape underneath. So if I click here, it will only propagate to this rectangle, and the rectangle underneath it will not receive a mouse down event. And I then just go ahead and do exactly the same for all the three events. Mouse down, mouse move also gets a stop propagation command, and mouse up will also get the same command. And you can see, hopefully, that this will cure this problem. So if I click on an overlapping area, only the topmost rectangle moves, and the bottom one doesn't move. So being able to stop propagation is a useful trick for many applications where you have mouse events, touch events going on. So that's pretty much the completed program that we want to look at. The only other thing I want to draw your attention to is the difference between mouse down, mouse up and mouse move events, and the equivalent set of events which are called touches begin, touches move and touches end. So what's the difference between these two? Well, as the name suggests, these mouse events correspond to a desktop system where you have a mouse pointer, and you're clicking on the screen and dragging things around. The touches events happen on a touchscreen device such as an Android device or an iOS device or a Windows Phone device. However, Gideros will automatically propagate mouse events into touches events by default. So here, if you were to run this on an Android device, let's say with a touchscreen, it would still work. You'd still be able to drag these things around with your finger. And the reason for that is these mouse, what will happen in the Android device is that a touch event will happen, but Gideros then processes that also into a mouse down event. So it creates a mouse down event as well, which this program knows how to handle. If you right click on the root of the project and select properties and go to input, you can see this checkbox here is telling you touch events generate mouse events and mouse events generate touch events. So if we run this program on an Android tablet, for example, there will be touch events, but they will generate equivalent mouse events which our program will handle. So everything just works on every device, whether it's a Windows PC or an Android tablet or an Apple Mac or whatever. But in some cases you may want to distinguish between touch events and mouse events, so you can uncheck these two boxes. To be honest, in most cases you just want them to be the same thing. You want the program to work the same way, whichever sort of device you're running it on. But yeah, in principle Gideros does distinguish between mouse events and touch events. So let's practice just changing this into touch rather than mouse down events. We'll have a touches begin event. And we'll get exactly the same behavior, but just to show you how it works. Touches begin, touches move, and touches end. So if these three events fire, then I will call on mouse down, on mouse up, and on mouse move, and on mouse up. I'm not going to bother changing the name of these things. However, there's a slight difference in touch events in the sense that if you look at the documentation, when you have a touches begin event, the XY coordinate come through as touch.x and touch.y. So there's a table passed through within event called touch, and within that there's a further field called x. So I'm going to have to change the code slightly. I'm going to have to change it like this. So I have event.touch.x, event.touch.y, and again. And you can see from this that touches events are slightly more complicated. And there's a very good reason why they're slightly more complicated. But if you just have a single touch app like we have, where you're only relying on one touch at a time, you only have one mouse pointer on a Windows computer, it's easier to deal with the mouse down, mouse move, and mouse up events. But if you're going for multi-touch, then you need to use the touches events. So that should, let me see, that should almost, I just need to change, no, it's not touches, it's touch, isn't it? Yeah, if I just change touch x to touch.x and y to touch.y, mirror this again, and hopefully that one doesn't need to change. I think that should still work. Let's see if that still does the same thing. Yep, so everything works just the same, and the reason it works just the same is because I've checked this box, mouse events generate touch events. So what's happening is a Windows computer, right? I'm generating mouse events. There's no touches events being generated as such. But whenever there is a mouse event, it will generate a touch event, and then my program knows how to handle these touch events. That's what I registered as touches begin, touches move, and touches end. So the question is, should you use mouse events or touches events? You can use either in your program. It doesn't matter which one you use if you only have a single touch program. And this app is a single touch, right? You can only touch one thing at a time. You can only drag one thing at a time. It's not designed to be a multi-touch app where you have multiple fingers on the screen dragging multiple things at once. If you have a single touch app, then you should just go for the mouse begin, mouse move, and mouse end because it's slightly simpler. If you do need to deal with multi-touch, then you will need to register these touches events. Touches begin, touches move, and touches end. And the reason is they give you more information, as you can see here. Not only do you get the XY coordinate of the event, but very importantly, you get the ID of the event. So if the user is touching the screen with two fingers, or he touches with his first finger, that will be ID number 1, and you get the XY coordinate. Then he touches with his second finger, then the ID will be 2, and you'll get the XY coordinate. So you can distinguish between those two touches going on, and you can deal with multi-touch systems, which of course you need for many iOS and Android apps. So if you're dealing with multi-touch, you must use touches begin, touches move, and touches end. If you have a simpler app, like this one where we only need to use one mouse click at a time, or one finger touching the screen at a time, then you can just get away with mouse down, mouse move, and mouse up. If you do want to learn more about multi-touch, what you should do is look at one of the example projects, a different example project, which is, you scroll around here for a while, the Touch Explorer project. And this is one that you have to export to an Android or iOS or Windows Phone device, a touchscreen device, and then when you run this project, you'll be able to see multi-touches happening at once. And this program is obviously based on touches begin, touches move, and touches end. So it says you need to run this on a real device, namely a touchscreen device. I only get one touch at a time on my Windows device, but if I ran this on an Android device or a touchscreen device, I would actually see multiple touches happening. So this is the example I would recommend if you want to learn how to do multi-touch. And if you just have a quick look at the code, we will see that you can see you've got on touches begin, on touches move, and on touches end. So these are our listener functions, and what's being registered is touches begin, touches move, and touches end. There's also a touches cancel.